All right, so here's an introduction to quadratic equations. And not in the sense of where we're going to factor or find the zeros, but just what the graph looks like. And we could tell a few basic characteristics of a quadratic function and the way it's going to look just by the information given here. So a quadratic function or equation, the graph it produces is called a parabola. Okay. Now, a parabola has a couple of key characteristics I just want to mention. A parabola is always symmetrical, meaning that if you cut it in half, each half will look the same. It may be mirrored, but each half will look the same. So it's symmetrical. The parabola also has a vertex. Okay, and the vertex is the very middle part of the graph. Also, the vertex will either be the very lowest point or the minimum of my graph, or the very highest point or the maximum of my graph. And we can tell all that information on what's right here in front of us. Now, let's take a look here. Usually, the vertex is at 0, 0. Oh, the vertex is always at 0, 0. But there is a number that can change all that. Now, notice how it's negative 2x squared. If there was a constant like plus 5 or minus 3, that would change where the vertex is. But because there is no number, it's blank, that's why I've circled it, there's nothing there. That means the vertex will stay at 0, 0, and that's where the dot or my vertex will go. Now, we can also find out how fat or how skinny or how wide or narrow the graph is based on the number in front of x squared, the coefficient in front of x squared. And that's what we've referred to as a in a quadratic equation. So, the number in front of x squared tells us a couple of things. The first thing the number in front of x squared can tell us is how narrow or how wide the graph can get, or how fat or skinny. So, if the number in front of x squared, the absolute value, is greater than 1, so if it's 1.5 or 3 or 5 or even negative 2, negative 7, if the absolute value is greater than 1, it's going to be a skinnier graph. And if the absolute value of a is between 0 and 1, it means the graph is fat. So the graph will be a lot larger than it usually is if the number's somewhere between 0 and 1. All right, so now looking at this equation, negative 2x squared, negative 2, its absolute value is bigger than 1, so that means my graph is going to be skinny. All right, so and there's one other thing a can tell us about. A can also tell us if the graph is going to open up or if it's going to open down. So if a is greater than 0, meaning it's positive, if a is positive, it will open up. Because think about it. Like a parabola, if you don't know what it looks like a giant happy face or sad face. If it's positive, you're happy. And so if a is less than 0 or negative, it opens downwards or it's going to be sad. So the a is negative 2, so that means it's going to be sad or open downward. Now, I'm going to draw a black graph, and this is what a normal negative x squared equation would look like. But because it's negative 2, I'm going to make it a little bit skinnier. And so that's my green graph right there. So that is a picture of what negative 2x squared looks like. Now, I could have plugged in points and plugged in x and got a number for y, but this is just a general overview of the characteristics of a parabola when a is a negative number and when it's something different than 1. So there are a few characteristics.